We live in an era of absolute climate control. We build towers of concrete and glass, engineered to keep the weather out. We lock our windows, turn on the AC, and seal ourselves off from the outside world. But there is a strange side effect to this isolation. By blocking out wind, rain, and fluctuating temperatures, we've created environments that feel stagnant. We achieve physical comfort, yet often experience a lingering sense of confinement inside our own walls. This raises a question about how we construct our lives. Modernity often treats the home as a fortress against nature, built to exclude the environment rather than engage with it. Long before the invention of the thermostat, architects on the Korean peninsula developed a different approach. They built the Hanok, a traditional residential structure that prioritizes airflow over airtightness. The Hanok operates as an advanced organic machine. It utilizes a system of natural regulation and porous boundaries to maintain an equilibrium between human comfort and the surrounding environment. The core principle of a Hanok is that the house itself functions as a breathing organism. This is achieved through its basic building components: raw, untreated timber and natural earth. This diagram illustrates how these materials behave. Wood and soil absorb ambient moisture when humidity spikes, releasing it back when the air dries out. Furthermore, the thick earth acts as a thermal mass. It absorbs intense summer heat and delays its release into the interior. Instead of heavy glass panes, the doors and windows are lined with hanji, a traditional paper made from mulberry bark. It filters the incoming air and allows a gentle microbreeze to pass through, preventing the room from feeling stagnant. Modern buildings rely on mechanical heating, ventilation, and air conditioning, or HVAC systems, to force air circulation. These machines consume massive amounts of energy to artificially replicate the regulation that natural materials provide passively. These material choices create a cycle of continuous biological respiration. The walls and pillars are constantly working to regulate the climate inside the home. Beyond the materials, the actual skeleton of the building is designed around flexibility. Rather than using nails or rigid metal brackets, the timber frame is assembled using interlocking wooden joints. When the ground shifts, the connections flex and disperse that kinetic energy throughout the frame, allowing the building to ride out the stress without cracking. This cutaway reveals two seasonal strategies side by side: the open maru and the heated ondol rooms. The maru is elevated to catch prevailing winds. It uses cross-ventilation to passively draw hot air out and pull cool breezes through during humid summers. In winter, life shifts to the ondol rooms. This traditional underfloor system channels hot smoke through flues beneath the masonry floor. It creates radiant heat that warms the occupants from the ground up, while the rest of the house continues to breathe. Combining an open wind tunnel for summer with a radiant heat sink for winter creates a responsive microclimate. It proves that surviving harsh weather does not require being trapped inside an airtight box. There is a concept called architectural psychology, the observation that a building's design shapes the physical behavior and mindset of the people inside it. Entering a Hanok requires a physical transition. You remove your shoes, step up onto the elevated floorboards, and slide the paper doors open. This friction forces a deceleration. It requires a deliberate movement that naturally slows down your pace. Due to porous walls and outward stretching eaves, your visual focus is naturally pulled toward the exterior. The architecture frames the courtyard and the sky, treating the natural world as a permanent fixture of the interior. In a modern apartment, you set a temperature on a digital screen and ignore the weather. Living in a Hanok requires active daily engagement. You open specific windows for the morning breeze and close outer layers against the evening chill. This constant, subtle interaction with the environment recalibrates your perception of time. As winter snow accumulates against the heavy eaves, the house remains part of the landscape, keeping daily life tethered to the slow turning seasons. The Hanok acts as a physical mechanism for environmental synchronization. It creates a space where humans must engage with natural cycles, providing a direct link to the natural world that modern architecture often obscures.